Hi, everybody. So today we're going to be doing homework for Chapter 6, Lesson 2.4. So we're going to start off with number 80, where we have to look at the graph at the right, and we already have these two triangles that are given to us. It says that we need to write the directions for translating the original, right? This one's labeled original, to make it into the new. So basically, how did we get this triangle over here? So the way that we want to start is by just selecting a point on this original triangle. It doesn't matter which one you start with. I'm just going to start with the bottom one right here. And I can see that automatically I'm going to have to be moving it to the left. So I'm going to say slide, because that's the move that we're doing, left. And then let's count how many moves we had to make to slide it with the point that matches up with the same point on our new shape, which I can see is right here, right? Those two match up based on the orientation of the triangle. So I slid left 2, and then I know I have to go up because my shape's up. So from here, how many slides up did I have to go? 1, 2, and up 2. Okay, and it should be the same for each point that you have. You can double check. Did we, for this point right here, slide over 2, 1, 2, and up 2, 1, 2? Yep. And again, for the top point, up 2, left 2. Yes, that works out. Okay. So next part, it says, what are the coordinates of the vertices or the corners of the new shape? So this is the new shape. So we need to name these 3 points. So this first one, the bottom one, we know is on the x coordinate, it is at -3. And then on the y coordinate, it's at +1 because we're moving up 1. So there's that first point. This second point right here is again at negative, right? Because we had to move from on the x-axis into the negative region. 1, 2 spots. So -2. And then from there, we moved 1, 2 up. So -2, 2. All right, our top spot then, right, this one way up here, we had to move again to the left, so it's going to be negative 1, 2, 3 spots, so -3. And then from there, we went up 1, 2. We can't really see that spot, but we can see the line. 2, 3. So -3, 3. All right. Then letter C, it says, on your graph, reflect the original triangle over the y-axis. What are the coordinates of the new triangle? All right, so first of all, reflecting, remember, if you have your shape like this, you are flipping it. I kind of did that backwards. You're flipping it, right, like this, over that point of reflection. In this case, it happens to be the y-axis, which we know is this line right here. So we are just taking this little triangle and flipping him right over it. Okay, so actually in this case, our point right here is going to stay on that line, right? Because if we're flipping over this axis, like, he's not going to go anywhere. This point down here, I can see I'm 1 away from my line of reflection. So that means I have to go to my line of reflection and go 1 in the opposite direction to flip it over. And then again, with the top one, I can see I'm 1 away. So it always stays on the same like latitude line. It's just the longitude line that changes. And then we can redraw our shape. It looks exactly the same. The size did not change. The shape didn't change. All right, then we have to name the new coordinates. So we have to name these points. So let's do the bottom one first. If I'm starting at 0, 0, I'm having to move over 1, right? So +1, and then down 1, -1. Okay. This point is going to stay the same at the origin, so 0, 0. And then my top one, I had to move over 1 and up 1, so 1, 1. Okay, so those are our new coordinate points. Now, for 81, it says that Hannah thinks that the solution to the system below is -4, -6. Wirt thinks that the solution is 20, 10. And we have to basically say who's right? Is Hannah correct? Is Wirt correct? And then what do the answers to A and B tell us about the lines of the problem? So we can use equal values method to check to see who's right. So there's a couple different ways, right? We could take these points and plug it into the equation, take his points and plug it into the equation, and determine who's correct that way. Or we could just solve it and see who is correct, okay? So we'll start by plugging these points in. I'll show you that method first. Okay, so with Hannah's, we're going to take her points that she thinks are correct and plug in the x. This is always the x, and this is always the y. So I'm going to rewrite the equation, and then in place of the x, I'm going to write -4. Everything else stays the same. In place of the y, I'm going to write -6. All right, and then we're just going to solve, okay, for the first one. So 2 times 4 is -8. 2 times -4 is -8. And then -3 times -6 would be +18, so +18 equals 10. When I go ahead and solve this, let's see, -18 plus 8, -8 plus 18 is 10, equals 10. So that part checks out. Remember, it also has to check out for the second equation, so we have to plug it into this one as well. All right, so 6, and then remember the y is -6 equals, and then the x is -4 minus 20. All right, so 6 times 6 is 36. We know it's negative, right, because that negative right there. And then negative times a positive is a negative. 4 times 4 is 16. And then minus 20. Okay, when we go ahead and combine these on the right side, -16 plus -20, when right, it's going to be a larger negative. So 10 plus 20 is 30, and then the 6, that checks out. So Hannah is correct, yes, because her points work, right? Now let's see if Wirt's, what his would look like. Just trying to keep it all straight. So this one right here is Hannah, and then we'll do Wirt over here. Okay, so he was saying that 2010 was a point. So let's double check his. So 2 times his 10, remember, was the x, or his 20 was the x and his 10 was the y. So plugging in a 20 minus 3 times my 10, right, equals 10. All right, so 20 times 2 would be 40. And -3 times 10 would be -30. So this would be 10 equals 10. So that checks out, right? All right, let's try the other equation. You have to try it in both because sometimes it'll work in just one and not the other. All right, so again, his y was 10, and then equals 4 times 20 minus 20. Okay, so we should have 60 here, right? 6 times 10, and then 4 times 20 be 80 minus 20. And then 80 minus 20 we know is 60. Hey, look at that. It works for both people. Okay, so then what does that tell us about the two lines, or the A and B? Well, that tells us that the lines coincide. Perfect. It means like there's any solution for that one. All right, flipping that on over then. Here we go. Here's a little bit of review. So for number 82, it says figure 2 of a tile pattern is shown at the right. If the pattern grows linearly, which is what we've been working on, and if figure 6 has 18 tiles, then find the rule for the pattern. So if we'd like, we can easily make a table, right, to figure out how many tiles are in figure 0 and what the growth is. So when we make a table, we want to include that 0 number. And we know that figure, let's go up to 6. Okay, so those are my x's. And then as far as my y's go, I know that this is figure 2, right? So figure 2 has 1, 2, 3, 4, 5, 6. So it can fill that in. And then it also tells me that figure 6 has 18 tiles, so I can plug that in as well. All right, so remember, to find the growth, we're going to say what's the difference between these two numbers here. So between 6 and 18, right, is 12 There's 12 numbers. And then we say how many jumps did it take us to get there? So 1, 2, 3, 4 jumps. So that is what we would divide our number by. Okay. So when I figure that out, I know that my answer would be 3, right? Because 4 goes into 12 3 times. So that is my growth. It's going to be a plus 3 every time. And I can double check it. So 6 plus 3, 9. 9 plus 3, 12. 12 plus 3, 15. 15 plus 3, 18. That works out. I can also go backwards by subtracting 3. So I could say 6 minus 3. And 3 minus 3 would be 0. Okay. So now that we have that, we have our growth. We have our 0 number filled in right here. We can now write a rule. Remember, our rules always start with y equals. Then comes our growth. So how many were we adding every time in the y piece? That was 3. So 3x. And then our 0 number. Since our 0 number is actually 0, we could write plus 0, or we can just leave it like this. Okay, y equals 3x. Perfect. All right, that one's done. Number 83 says that we need to simplify the following expressions for x if possible and show our solution or check our solution. So we're going to be solving for x. Okay, we see the first thing, parentheses. So when we see that, that's the first thing we need to deal with, is distributing whatever's in front of it to everything inside of the parentheses. So that means the opposite of 2 is negative 2. The opposite of negative 3x would be positive 3x. Now, the negative does not get distributed to this other x because it is outside the parentheses. Okay? It's only to things inside. And then we just rewrite the rest of our problem. Okay, step number 2, we need to combine like terms. So get the terms that are like each other, right, that are either x's or numbers together. So on my left side here, I don't have any numbers that I can combine with the negative 2. So we just rewrite him, but I do have some x's I can combine, right? 3x plus a 1x would be 4x, so plus 4x equals 9 minus x, nothing to combine there. Okay, now we need to start flipping back and forth in our equation to try to get the x's together. So I'm going to kind of continue it up over here probably. There, we'll just do it up here. So I'll just rewrite it quick so that you guys can follow. Okay, so I'm going to move this x, first of all, over onto this other side. And we need to add, right, because of the subtraction sign. We look at the sign in front of it, and that tells us what to do. So we're adding x to both sides. All right, so we still have the negative 2. Now our x's, 4 plus 1x is 5x equals 9. And then I want to move my numbers over to the other side. So since there's a subtraction sign right there, we're going to add 2. That will essentially make this, right, a 0 pair. So I'm left with 5x equals 11. And then for my last step, I need to divide to get that number, that coefficient, onto the other side, which is going to leave me with x equals 11 fifths. Okay, so you could leave it like that, or you could put it as a decimal. It would be, or 2.2 would be the decimal. Okay, yeah. Okay, and then we can't forget we have to go through and check it. So to do that, we have to plug it back in. I'm gonna run out of space. I might have to use this space up here to check. Okay, so we rewrite our problem, and then instead of x, I'm gonna use the decimal just because that's gonna be a little bit easier. So, oops, parentheses, negative 3 times 2.2 plus 2.2 equals 9 minus 2.2. Just plugging in that x value for everything, wherever there's an x, we plug that number in. Okay, so we have to start with our parentheses. We do negative 3 times 2.2, which, okay, so negative 2 minus 6.6 plus 2.2, oops, equals 9. Well, I suppose I could do, yeah, 9 minus 2.2. Okay, then we distribute, right? sorry, we can solve this part. I forgot about that. Yeesh. So 6.2 minus 6.6, and then would be 4.6. Just rewriting everything else. Okay, now we can do our parentheses, right? Distributing that, so that makes that negative 4.6 plus 2.2 equals 9 minus 2.2. And then we can go ahead and combine everything here. So we're adding 2.2 to negative 4.6, so negative 2.4. And then subtracting on this other side. Oh, sorry. Yeah, 2.2. Okay. I'm trying to figure out where my math messed up here. Oh, I totally. Okay, I'll have to go back and fix that part on my other sheet. Okay, next part here. So to solve this, for our 6 over, we're trying to get this x alone, right? Oh, never mind. You don't even have to do this one. Okay, we'll just not do. I'm trying to do the ones that you guys have to do this time, so you don't have a whole bunch of extra work. All right, I think I had you do C. All right, we'll solve that one anyways. Sorry, it's kind of confusing right now, guys. All right, so to solve this, remember, we're looking at the number that's outside of the parentheses, and that has to get distributed to everything inside. So 5, the negative 2x times x would be negative 2x, right? Because it's being multiplied. And then the negative 2 times the 6 would be negative 12. There we go. Okay, back on track. So combining like terms, we have a negative 12 and a positive 5, which we know can fit together. So when we combine that, that would be a negative 7 minus 2x equals 14. All right, we're trying to get our x's alone, so we're going to want to move this negative 7 onto the other side. We are adding 7 because of that subtraction sign right there. So plus 7 on either side leaves me with negative 2x plus 21. Okay. And then we would have to divide by negative 2. All right, so that leaves me with x, and we're just going to leave it as the fraction. We don't have to convert it, or if you want to put it as a decimal, you certainly can, but you don't have to. It would be negative 10.5. And then we could plug this back in for our x, right, to double check and make sure that it was correct. All right, and then for our last one here, I personally would probably fraction bust this one, so I'll kind of show you just as like a little reminder on how to do fraction buster, just because 0.3 isn't a very nice number. So in order to fraction bust, we could use our 2 denominators here and multiply it by everything inside, or everything, all of the rest of our numbers. So everything gets multiplied by 2 and 3 because those are our 2 denominators here. So just write the 2 and the times 3 next to every piece of your problem, and then we determine what we can eliminate. So we can eliminate the 2's from this part because 2 over 2 is going to cancel out 201. We can't cancel out anything here because we don't have denominators. And for our last piece, we can cancel out our 3's because 3 over 3 is 1. Then all we need to do is multiply. So numerator times our number that we're multiplying. So 3 times 1 is 3x. We still have a negative, so 4 times 3 is 12. 12 times 2 is 24. And then 3 times 3 is 9. 9 times 2 be negative 18 because of those negatives, so I'm just keeping those with. And then here 2 times 1 is 2, so minus 2x. See how now we got rid of the fractions? It works kind of nice. All right, so now we need to get the x's together on one side. So I'm going to be adding 2x on either side here to move him over, so that will leave me with 5x's. And the rest of it here will stay the same, right? Then we're going to move our numbers over, so we're going to add 24 on both sides, just like that. So I'm just going to rewrite over here what I have. So 5x equals 6, right? Yep. And then I need to divide by my coefficient, which is going to leave me, you could either leave this as a fraction if you want. The decimal conversion would be 1.2. If you want to leave it like that, you can do that too. All right, one more page. No, we're almost there. Okay, a little bit of review from, actually, this is more like 7th grade material. So with our box and whisker plots. So Kevin found the box plot below in the school newspaper. So we have hours spent watching TV each week. And you can kind of see this box plot. This line should really be like right here. It should match up with the 20. But anyways, based on the plot, what percentage of students watch more than 10 hours of television a week? So here we can see 10 hours. How many students watch this amount? Well, it's kind of nice because this is our third quartile. So we can see that if this is our halfway amount, right, this is like 50%, then that means that from here to here would be, if this is about like your 75%, 75 to 100% would be 25% that would watch 10% or more hours of TV. Okay. And then this next one says, based on the plot, what percentage watch less than 5 hours? So 5 hours here, which is our halfway point, right? Over to 0 would be 50% because of this line. That's what that line right there tells us. That's halfway. So 50% of students actually watch less than 5 hours. All right, so can Kevin use a box plot to find the mean or the average number of hours watched per week? Unfortunately, that is not what a box plot will tell us. So no, we don't have individual data for students, so we can't see that. Okay, just something like that will work. Little explanation. All right, last part, we just have to solve each equation. Just solving for x. Oh, not so bad. Okay, the first one, we don't even have much combining to do. All we have to do is move this 0.85 over onto our other side. So in order to do that, we're going to divide on both sides by that coefficient, even if it's a decimal. We could have like converted it, right? That would be okay too. And then when we divide that, here we go. Those are pretty easy. You just punch them in. All right, and then the same thing. This is being multiplied by, so we have to divide by 7/6. We could also, if you like wanted to, 7 divided by 6. It's this decimal. It's like 1.16 repeating. So we could also do it that way. But in the end, when we divide that out, we should get 120. You can kind of punch in like the 140 and then divide by the 7/6, essentially. And then that's what we get. All right. Anyways, thank you guys for watching. Sorry, I was a little disorganized today. It's been quite a day. All right. Next one is coming soon.